So when we think about the Daytona to Mims mission, and I look at the overall mileage, 79 miles, that doesn't stand out as something that's that crazy. Census has performed missions similar to that in the past, customers as well. The rest of the industry has milestones that look like that or even more. So when I think about the value of doing something like the Daytona to Mims operation, what stands out to me is the aggregation of everything that went into it. So we cross in and out of controlled airspace, we turn a deliverable around in a meaningful time period, we're tracing critical infrastructure right away, which is incredibly relevant to not only Census and our customer base, but really how the proliferation of UAS has advanced in the last few years. It's a societal and an economic impact. That is really what excites me about that operation, is not just the mileage. It's everything else besides the mileage almost. Ultimately, we're trying to provide coverage over things that satellites and helicopters and fixed-wing planes traditionally have maintained, that sphere. The only way that a drone, Sentaero 6 in this instance, is able to compete on the coverage side of that is to truly look at it holistically from how do we get these assets distributed across these wide areas, these vast areas, 40,000 miles, 60,000 miles. If you're trying to fly that per year, what network has to exist to create that coverage? We look at the fact that a Sentaero 6 can not only take off and land vertically, but it can fly for up to 2 hours. And the thing that gets me the most excited is the fact that now we can carry a payload that turns 2 flights into 1. We're able to get high resolution RGB and high resolution LiDAR achieved in the same flight and turn it into 6 or 7 use cases available across different business units at the utility. Couple that with the fact that a handful of these aircraft can cover a 40,000 mile system on a yearly basis. That inspection cycle that is traditionally on a 3 to 5 year basis is now down to yearly. In some cases, if you have high fire threat districts or areas of aging infrastructure, you can bring that 3 to 5 years down to 6 months. And bringing that inspection cycle down is really what drives risk to the floor.
Whenever we do our demos out at our main training field, it's safe, and it's safe for a reason. It is a very low risk environment to show those types of things. This steps up, we're crossing approach departure routes, we're coordinating with ATC. It can be hard to schedule that type of thing as a static demo because the day before we executed our operation, there were wildfires in the area, and there were lots of manned aviation, especially helicopters, helping to put the fires out. So we could have had a whole demo planned around that in a real world environment and got to do nothing. We ended up getting an authorization to fly through what is typically zero grid on the US facility map to 200 feet absolute AGL. So that allowed us to continue to collect data, obviously to even be able to cross over center line to get down to Mims. Again, when I say center line, that's off on the west side of 95 over the approach departure route there. Then we started looking at population density again. Obviously, it's very busy over Daytona. I mean, it's not New York City dense, but Daytona is a pretty dense area. Crashing over 2 interstates, I-95, I-4, several state roads, US 1, large roads, being sure also that we're within our waiver of not more than 120 seconds over top of roads, which we were nowhere near that. Generally try to cross those at 90. You're not flying over top of 95, basically.
Going to arm in 1, 2, 3, arming.
So throughout the operation, I hate to use the word boring, but it just continues to go as expected. Routine comms. I mean, the majority of the talk was just everybody saying, hey, you see that aircraft? Yes, I see that aircraft. Repeating back telemetry, reading battery voltages, but it continues to be very clean.
Sending it to landing orbit. Dropping altitude, 250. Have eyes on, transition. I have hover, position.
10, 33 volts, 5, and ground. Disarm.
Congrats, y'all.
Raw data quality that we're getting off the fixed wing was amazing, but then the AI side of it, the SenseWise side, where we boil it down to a usable dashboard, that's where the value creation comes. It's not in the 3.5 billion points, it's the guidance that the 3.5 billion points give us that we need to take an action?
We're able to prove out the turnaround time from this mission of a few hours to get a processed LAS file, so actually processing the raw data, and then from that, about 15 minutes to get to a dashboard. That's where SenseWise comes in. It allows us to identify things like vegetation encroachments and have a user much more quickly just go through, validate those potential detections, and pass that to where they need to go, instead of spending weeks going through, parsing through thousands of miles of data. We can do that in hours.
You're not looking at a 3.5 billion point cloud anymore. You're looking at some indicated encroachments on a dashboard, and you click on one of the encroachments and here's a cutout of the LiDAR. And you know, we're supercharging the human to be able to decide, is this, you know, a problem I care about or not? Or is it a bush that's never going to grow tall enough to matter? And that combination of quality and scale, and then, you know, very, very slick workflow to make it all consumable. It's been years in the making, but here it is.